In the last lesson, we learned about balancing redox reaction, how we just have regular redox reaction. To balance the regular redox reaction, we just have to split the redox reaction in terms of reduction and oxidation, and then rebalance the electron, and that's it. But now we have redox reaction that happen in either acidic solution or a basic solution, and that kind of changed everything, because in an acidic solution you have an excess H+, where in the basic solution you would have OH- ions. So how is that going to change the steps in balancing redox reaction in this specific condition? Well, first of all, the good thing is that both of them are very similar, except for the basic solution, which we will cover in more detail, and it just have one specific step that's being added to it, which is for every hydrogen ion plus you add OH to both sides, and if the OH and H plus on the same side, we would change them into H2O, but we'll get to that later. Now let's focus on the acidic solution. But if we look at step 2, that's when we see the changes. That is, we are balancing the elements first, not the electron, and only that we are looking for any element that are not hydrogen and oxygen. Because in step 3 and 4, for every extra oxygen, remember we have the reactant side and product side, we compare both sides. For any extra oxygen, you would add water, because the oxygen in water to the other side, which has lower number of oxygen. And then for the same thing, for extra hydrogen, you would add H plus to the side that has lower H plus, okay? Not until step 5, that's when you look at the electron. But when we do electron, we are doing something different. That is, we are using the negative properties of electron to cancel out the charges. Where are the charges coming from? More likely it's coming from the positive charges, especially that positive charge right there, okay? Not until step 7, when we go back to the half cell and look at the electron, and we just do the same thing we did before. And lastly, cancel like terms. Now let's do an example problem together, okay? And notice how I color code everything for you. So I'm going to put this over here, and hopefully you can see it, and I'm going to do this over here, and from there we are going to do with step 1. And of course step 1 is assigning the oxidation number all the time, because we need to do that first before we can do anything in terms of dividing or half reaction. So here I have -2 plus 5, and here I have 0, -2 plus 4, and here I have plus 1. And we are going to start with our Leo, which is oxidation. So I have my Leo, okay, right there. And the oxidation in this case is going to be from Ag here 0 all the way to plus. So it's become more positive. That means lose a negative electron. So we have Ag, okay, and it's going to go to Ag plus. Notice how I don't write anything about the electron. If we go back to our steps, we don't see electron until step 5. In this case, the Ag is balanced. We don't have oxygen, we don't have hydrogen, so we can go down to step 5. So in step 5, what we have here is balance out the charges using the electron. Notice how this is 0 charges, okay? And this one has a +1 charges. So to make this equal to 0, or to make this side equal to 0, we need to add a negative electron here. And that will give a total of 0 here and a total of 0 there. That's how we balance the charges on both sides. Okay? And that's it. That's all we have to do in this situation for Leo. Now let's go back and do the other part, which is the reduction or the GER part. Okay? So what is it that we're going to do in terms of the GER part? So I'm going to write GER for reduction. And of course the GER is going to be that part right there. We have that +5 going to +4, become more negative, and that will give us the reduction. So we have NO3 minus going to NO2. There you go. And then now we go back to steps. The N is already balanced, So again, we balance any other element besides hydrogen and oxygen. Now we go to the next step, which is step 3 and 4. Let's look at the oxygen. Here we have how many oxygen. So step 4, we're using the green color. In this case, here I have 2 oxygen on that side, and here I have 3 oxygen. So therefore, I need to balance it out by adding another oxygen. And how many water we need? Each water, which is H2O, right? It has 1 oxygen, so I just need to add 1 more water molecules right there. And now I have 3 oxygen and 3 oxygen. And that is step 3. And then we go to step 4. Because we're adding water to it, it will change the number of hydrogen. Here we have 2, over here we have 0. So how can I make this side to have 2 hydrogen as well? Of course, I'm going to add 2. So for every extra hydrogen, I would have an H+. So in this case, I'm going to add 2H+. So now both of them has hydrogen. And that's it for step 4. Now let's go back to step 5 to our charges. So we had to balance out the charges. Okay, in this case, if we look at this one has a net charge of 0, and this one has a net charge of 0 as well. So the total is 0 on this side. But over here we have, there's no coefficient there, so we just know it as -1 or 1 minus. Here we have plus, but there are 2 of them, so we have 2 plus. And a 2 plus and a -1, that cancel out to be a 1 plus. So how many more electrons do we need to cancel? That 1 plus, of course, is just 1 more electron. And that's all we have to do for step 5. So we have our half cells all the way to step 5, okay? And the last step is just combine them together. And when we combine them together, remember the basic redox reaction? We just make sure that the electron need to be equal to each other. Here we have plus 1 electron. Here we have the 1 electron again. So they balance. Now we just cancel out like term. Of course, the electron cancel out. Can we cancel anything else? Okay. Basically, cancel out reaction with the product. Usually, I just cancel out the electron because everything else becomes very confusing to cancel. But when we write down again, starting from the top first, and then going down to the bottom. So in this case, my top is Ag, just to keep information organized. And we go down to the bottom. Remember, we canceled the electron already. So we have 2 plus that right there. And then we have NO3 minus. There you go. We are done with the reactant side. Now we go to the product side. In this case, we have Ag plus, that part right there. And we continue to the bottom, NO2, and then plus H2O. Beautiful. And do we have any like term that we need to cancel out? That means do we have water over here? Do we have water? No. We have Ag, but that's Ag plus. So let's check again. We have 1 Ag, 2 hydrogen, 2 hydrogen, 1 N, and how many? Oh, we have 3 here, and 2 plus 1 gives you 3. And there you go. It is balanced. Now let's try a more challenging problem. In this case, I have this chemical reaction here that needs to be balanced. And of course, how do I know that this is going to be an acidic solution? It will tell us, okay? So in this case, we go back, and the very first thing we have to do is assign the oxidation number. So we have this is -2. Well, this is, yes, this is -2, and this is +6, okay? And this is +1, this is -2, and this is +3, okay? Then of course we just have this is +3, and then we have this -2, and this is +5. There you go. And if you have a difficult time assigning the oxidation number, please go back and review that specific video, okay? Now let's go back and look at this problem together. Go back to step number 1. Now we can separate them into what you call it, half reaction. So our half reaction, again, going back to Leo. So what we have here is Leo. What happened in Leo? We have loss of electron. In this case, to lose a loss of electron is going to become more positive. And which one become more positive? In this case, we have hydrogen. Hydrogen, we don't look at it because it's not there anymore. And How about the nitrogen? Nitrogen plus 3, and we have plus 5. There you go. It becomes more positive. So that is our oxidation. So I'm going to write that down. HNO3, or NO2 specifically. We're going to NO3 minus. There you go. Now let's go back to our next steps, okay? So our next step is balance out other element. In this case we have, well, let's go to our next step. The next step is to balance all elements except for hydrogen and oxygen. This N is 1, and 1 over here is balanced. And we have H and O. Let's worry about that next. That's in step 3. So step 3, we focus on the oxygen. In this case, we have 3 oxygen here, and we have 2 oxygen there. So we need to make sure that this side also has 3. And how many more water do we need? Of course, it's just 1 more water. So we add 1 H2O. Okay, each water molecule only has 1 oxygen. And that's it. For step 3. Now we go to step 4, which is now the hydrogen. Over we have 2 and 1, that gave us 3. And if we need 3 more over here, what do we need to do? Again, going back, every extra hydrogen we need to have 1 H plus on the other side. In this case, of course, this side. And what we have here is, what color do we have? Green now. So here we have 2 and 1, that's 3. So we need to add 3H plus on this side. Okay? And that's it for that specific step. Isn't that easy? Now going to step 5, we need to balance out the charges. In this case, this has 0 charges. This has a net of 0 charges. So this I have 0 charges. Over here we have a minus net charge, but there's no coefficient, so that's minus 1 or 1 minus in terms of charges. Here we have a plus. There are 3 of them, so that tells you there are 3 plus. And the total in this case, minus and 3, that will cancel out to what? That will give us 2 plus. So how can I make this side equal to 0? Of course, I need to add the negative electron. And that negative electron, how many electrons are we going to add? Of course, it's going to be 2 electrons. There you go. And that's all we have to do for this half reaction. Now let's go back and look at the GUR part, which is the reduction part. Okay, so for the reduction in this case, it's going to become more negative. And which one has more negative? Let's go back and look. Here we have plus 6. Oh, and here we have plus 3. There you go, become more negative. That's easy. So we have GUR, which is in this case Cr2O7, 2 minus, and that's going to Cr3 plus. Notice how in normal reduction reaction, we just focus on the individual atom in a compound. But in this case, we copy down the entire compound. Okay? So that's one very important information that you need to know. Now let's go back to step 2. So step 2 is balance all other elements. In this case, the other elements are chromium. Here I have how many chromium? I have 2 chromium. And of course this side is going to be 2 chromium as well. Isn't that easy? That's step 2. Again, we're not focusing on oxygen and hydrogen in step 2. So now let's look at step 3, which is the oxygen. Here I have 7 oxygen. So how am I going to add 7 oxygen this side? Of course, I need 7 water molecules because each one can only give me 1 oxygen. And there you go, 7 oxygen and 7 oxygen. And that's going to trigger to step 4, which we now have to balance out the hydrogen. Here we have 7 times 2, that gives us 14. So over here we need 14 hydrogen. And again, each hydrogen, we will add 1 H plus. So in this case, we're going to add 14 H plus. Now both sides have 14 hydrogen. Isn't that easy? Now let's go to step 5. So step 5 is balance out the charges. And this is where it gets tricky because we have a lot of charges involved in this case, right? So what we have here is a minus 2, okay? Or, yeah, minus 2 or 2 minus in terms of charges. And then here we have plus, but there are 14 of them, so we have 14 plus. And that cancel out. Give us 14 minus 2, that gives us 12 plus. on that side, right? Let's go back on this side. We have right here 0. Okay, that's easy. Here we have 3, but we have 2 of them, so that will give us a total of 6 plus. So here we have 6 plus, here we have 12 plus. So what do I need to add? Well, how many electrons I need to add to make this into 6 plus? 12, so we need to add 6 negative. There you go. We're gonna plus 6 negative electrons. And that will bring this side to have plus 6 or 6 plus charges. And now the charges cancel out. And there you go. You have your half reactions done. In this case, this is our Leo, okay, and this is our Ger. And the rest is just combine them together. So again, combine starting from the top. Oh wait, look what happened to the electron. Here we have 6 and here we have 2. So we need to balance that electron. So what do we need to do? So how can I make this into 6? Of course, I have to multiply everything by 3. So now that's going to be a 3 there, that's going to be a 3 there, that's going to be 3 there, that's going to be a 9 there, and that's going to be a 6 there. Oh, good thing we catch that. So now let's go back and combine our half reaction. Of course, we can cancel out the electron. We don't need to write out the electron. Okay? So starting from the top, we have 3H2O plus 3HNO2. Okay? Now going down, we have 14H plus, and we have Cr2O7 2 minus, and that's it for the reaction side. Let's write the products down on the bottom. So starting from the top, we have 3NO3 minus, and we have, remember, 9H plus. Then we cross out the electron already. Let's go down here. Then we have plus 2Cr3 plus 7H2O. And there you go. And that's it. In terms of combining, now we just need to cancel out like term. Well, let's start with the water first, okay? I'm going to use a different color just so we can see it. Red, let's go green. How about that? So in this case, we have 3 water, and that's 7 water. And that's going to make this have 4 water left. So we have 4 water H2O left there. What other like term do we see? Oh, I also see the hydrogen plus right there. This has 14, that has 9. So therefore, how many do we have left on this one? That's going to give us 5 hydrogen ions plus left. And any other like term that I have? And that's it, right? So let's rewrite our answer, a really long one. So we have 3HNO2 plus 5H plus 2O7 2 minus, and going to our product, I think we can actually fit them all. Let's see if we can fit them all. 3 minus plus 2Cr3 plus and plus 4H2O. And that is our answer. So, well, we're missing a minus 2 right there. And that's our answer. As you can see, this process is pretty easy, but you need to be patient with the process to solve this problem. Okay? And again, when you take notes, make sure you use different color, so that way you have a better understanding when you go back and look at your steps again.